measure when you're looking through the clinometer to make sure that it's a flat area. So that was my problem, but
Yeah, that's kind of mine too. Just making sure that the clinometer was always level when you were measuring the height of the tree.
Yeah. Yeah, this is very difficult. I run into the same problems also. Where did you guys come up with the design of this chronometer? I've never used one like this before, but the way that I see the way that it works, it's perfect for the type of forest you guys are doing.
well, yeah, this is the clinometer, and it was made by one of the classes here, but I don't know how it was designed specifically.
You're a pre-algebra student that might want to explain it.
If pre-algebra students have any input, Cyrus, you want to let them know?
I've been there, sir.
Alright, this is how we did it. We got one of these levels. Then we attached the straws to the triangle right here. Then we taped them down so we can look for them to see the top of the tree. Then we taped them to the level, so it was leveled. So every time you look you look for the straws, this little top tube right here, it would have to be in the middle for it to tell you're looking at the top and that you're leveled.
Okay, that's perfect. And you guys use this plus your height to kind of estimate, based on an equilateral triangle, how tall the tree was.
Yes.
So that's perfect. That's a really good design. I like that. What about the way you're measuring the tree? I noticed that you guys use the circumference of the tree. Is that right?
Yes.
Okay. Why did you decide to do that? Was that kind of the suggested method, or did you find it easy to do the calculation?
Yeah, we added, once you did the circumference, you added, what did we add again?
How long the trunk was?
Yeah, you looked at it eye level, and then you did the circumference, and then you measured that, and then you would use that in your equation to figure out the total carbon.
Okay, that's great. What we do is we actually have, I brought with me here, this is called a diameter tape, or a diameter measuring tape. So normally, instead of just measuring distance, it actually, when you wrap it around something circular, it actually tells you the diameter rather than the circumference. So it's the way we do it in the forestry industry to kind of to measure diameter kind of at chest height is a standard way. But your way works just fine as long as you're able to easily calculate the circumference into the radius and the radius into the cross-sectional area of the tree. It's very good. Nice job.
Thank you.
Now, how's it going, guys?
Good.
Great. So, if I go back to your chronometer real quick, and the way that you measure the distance to the tree, the way we use a chronometer, it's a little bit different. I'll show you real quick. I have an example over here with me. Just show you. Start over here. Okay, can you see my screen?
Yes.
Alright, so this is a chronometer. This is made by Sunto company in Finland. They're really, really, really small, and they're really, really expensive. I don't know why, but this is what they look like. They're really thin, and you kind of look in the black part on the bottom. And when you look inside, it actually tells you on the left side how many degrees up the tree is, or on the right side of the scale, what percentage grade you're looking at to get to the top of the tree. And it's just a way of estimating, so you're not fixed to being perfectly level like the chronometer that you guys are using. And so you can kind of, like my friend here, you can kind of be out in the forest, you can stand anywhere you want and read the angle. But we do it that way because we have a different way of measuring the distance to the tree than you guys. But you basically, if I understand right, you mark from where you're standing and then you walk. You walk to the tree. Is that right?
Yeah, we count how many strides until we reach the tree. And we mark our spot with a cone.
Okay. And then, how did you find that worked? Was it pretty accurate or not?
So far, it's been working out. We've only done a few trees so far in our section, and when we calculated those out, they seemed to come out pretty accurate.
Okay. How do you know how long what an average pace or an average step is? How do you know how long that is? Did you calculate out an average for each of you?
Yeah. Well, we put tape down in the hallways, and there was a certain distance, and we had to count how many strides it took from one end to the other, and then that was our average stride for that distance. Okay.
That's perfect. Again, that's really, really good. Excellent job. The way we do it out in the forest, because the ground is always going up and down like this, and we can never walk in a direct line, and this causes all kinds of problems, is we have a way of measuring the person with the chronometer. He or she also has a special device called a hypsometer. It looks like this. This one is a special laser. It's got actually 2 lasers on it, and they shoot at the tree, and then they receive the laser like this. And you can look inside of it like this, and I'm pointing at you right now, and I can tell you how far away my computer screen is from me, but I can't tell you how far you are because it doesn't shoot all the way to the United States. But basically, it's a way that if we look again at my screen here, if we look again at my screen, yeah, can you see that?
Yeah.
It's a way that we can measure using the chronometer that we use. Even if the ground is flat, we can measure top to the bottom of the tree or the distance directly. We can go downhill, or we can go uphill. Because that laser shoots directly and tells us exactly how far away the tree is from us, so we know like that. So, great. Hello. So, what did you guys find interesting about this? Did you find anything difficult?
Like some of the trees, it was kind of difficult to find like the height with all the other trees from depending on the angle you looked at it.
Uh-huh.
Yeah, I also thought that was difficult.
Okay.
I found it difficult, like the chronometer, getting it, like in the middle of the, what is it called? Level.
Keeping it level.
Right.
Yeah.
Okay. Yeah, it's difficult. What about when you were kind of deciding where to put the plots? Did you have any difficulty? Did the plot run through a tree, or did you have any problems with that?
No problems because Mr. Harold had already done that for us.
Okay. Okay, good.
Did anyone have that problem?
Yeah.
Who did? Who had that problem?
What? Will Gorowski.
Will G did? Come on, explain it, Will.
Okay. There were certain times when there would be a plot and there would be a tree in between the 2 plots, and you had to decide if that tree belonged to whether the plot like L or M or something.
How did you decide?
That was pretty much up to the groups. We could be like, okay, you guys can have it. It's mainly on your side, or it's mainly on our side.
Okay, that's a good way to do it. Yeah, when we're measuring, we always decide, okay, does the plot line go directly through the middle of the tree, or does it go through? If it's more than half in, then we say, okay, the tree's inside. If it's more than half out, we say it's out. This can be really, really important, because if you just take anything and you just say, okay, it's all in, then you overestimate accidentally how many trees there are in your plot. Your numbers would get too high. Okay, great. Hi.
Hi.
Do you guys have any questions from your group? If not,
No.
if not, I can tell you a little bit more about other things that we do when we're measuring. We use this device called a densiometer. It looks like this. It's small. It fits in your pocket, which is nice. It's made out of wood, so it's light. But on it, there's a mirror. Can you see it? And it's a concave mirror. And you hold it. It's got a little level, kind of like the level you guys use. And on the mirror is a bunch of scratches. Can you see the scratches?
Yeah.
Okay. Basically what I do is I hold this out like this, and I look up, and I can see the top of the canopy, or I can see directly above me. And what I do is I count on these, where these lines overlap. I count all the spaces where I can see the sky, where there's no leaves. And then there's a little equation on here for me to help calculate basically the density of the tree cover over me. And that helps me understand the different types of forests that we're in. It's a really useful tool for estimating the quality of the forest or the health of the forest area.
Okay, well, I can tell you about how we kept track of the trees, like which ones we did and which ones we didn't. Each group got a number or a letter, and then a letter. And if we did the tree, we would put like B1, and then the next one would be B2, and just keep going up with the numbers. So then we know which tree we did.
And you're in Team B?
Yeah.
Just for example. Okay. Okay, good. And how would you know, let's say you wanted to know how much the tree grew and you wanted to come back next year. How would you know that you were at the right tree?
Not sure, because we were just using chalk.
All right. I've used chalk out here, but we only use it, and we only hope that it stays on a tree for at least a day. When we do these projects, the projects are required to exist for at least 30 years. That means I have to be able to track the same tree out of tens of thousands of trees for 30 years. And I'm only about 30 years old, so that would be like measuring the same tree for my entire life. And that can be really difficult. But we have different ways of doing that. One, we use GPS, so we mark and we keep that data stored in the computer. Another way we do is directly in the field. We use metal tags. I'll show you real quick. Oh, there we are. So this is a student from the National University of Laos here in Vientiane, and he came with us, and he was one of my field assistants. What he's doing is he's scratching a very similar code like the one that you were talking about. He's scratching it into this little metal plate. And then he hammers that into the tree. It doesn't hurt the tree because we use nails that are made out of aluminum so they don't rust. And we leave the tag there in the tree. And it has to be above kind of the area where a chainsaw might cut, because if we do it lower and a chainsaw hits this by accident, because maybe there's some people in there that want to cut down this tree illegally, then if the chainsaw hits this, it can really hurt people. So we make sure to put it kind of way up at eye height, so it's a bit higher. But you can see there's a code in there that's very similar to the code that you keep track on for your work. Great.
See the code? Can you ask him?
Can you see that?
Yeah, someone's too small. Ask him to read it.
This particular tag actually, this was his first time doing it, which is why I was taking photos. But he put it in a little bit too far. Normally we want to keep it out a little bit, the nail, kind of about half of that distance, because the tree will grow, and if there's no room for the nail to grow or get pushed out with the tree, then it can actually pop the tag off. But you also don't want to leave it too long, because in this forest where we're working right now, there's a lot of elephants. And the elephants like to come up and scratch themselves on these nails, and then that can knock the tag off as well. Okay, thanks.
We don't have that problem. Tell them there's no elephants. Tell them there's no elephants. Just squirrels.
Hi guys.
Hi.
Hello.
Hang on, I'm just trying to put my camera on in a few seconds. So, what do you guys think? Are there parts of your survey design where you think there might be some error, or there might be some inaccuracies?
Maybe like if we measure something wrong or do the math wrong for something. But, yeah.
Where do you think the most dangerous part in terms of the most likely spot where you might have some data recording errors? What do you think? Which particular measurement?
Probably like the height of the tree. We'd probably mess up.
Yeah, the height of the tree. Yeah, because if that level isn't just quite level, then it might be just a little bit this way. It might be just a little bit that way, right?
Yeah, and then the calculations can get messed up.
Yeah. I think for your measurements, it will be okay. That is definitely an area where I thought, okay, maybe there's a little bit of error in there in the measurement. But I think in terms of the amount of data that you guys are going to be collecting, that's an acceptable amount of error. So I think that's fine. Great.
Gabe, I have a question for you.
Okay.
Can you explain to the class how you develop your plots that you're going to be collecting data on? Do you use a satellite image? Do you divide it? Can you just kind of explain that process to us?
Sure. So we actually have a pretty complex job when it comes to deciding where we're going to put these plots. First, you guys have a pretty big park. We have an area that's much larger. I would say it's almost probably the size of Southeast Michigan that we need to measure. I'll show you a picture here how we do this. This will give you an idea of the types of areas, the scale of the types of forests that we have to measure real quick. And I'll show you how we design the survey, just so you know what I'm talking about. Otherwise, who knows what I'm talking about? Okay, here we go. So this is an area that we work in. Currently, you can see a lot of deforestation here on the left side. On the right side, this is all natural, pristine forest. This is actually a project area that I worked in Borneo, where agricultural conversion was a big problem. Here's the area where I work in Laos. You can see there's a lot of forest there. It's very hilly, it's very mountainous, and it's very difficult to survey. We need a lot of equipment, and we need a lot of team members. I think you guys have 2 team members, right? Or two to 4?
We have 4.
Yeah, we have 4 people in our groups.
In our groups, we have 10 to 14 people in one group, because it just takes that many people to carry out equipment and supplies out into the rainforest. Here's what it looks like in terms of how big the trees are. And this is what it looks like inside when we're trying to measure. It's really hard to know where's the top of the tree, where's the bottom of the tree. Sometimes we can't even tell if the tree is dead or alive because we can't see the top of it. You know, we can't even tell if there's leaves on it. When we're trying to design the survey, we have to look at a lot of satellite imagery, and we have to also keep in mind the different types of forests that we're surveying, because we might accidentally, for example, have a situation like this. Can you see this?
Yeah.
Where, like, we have a very big transect. Yeah, I'll show you the transect design first. Okay, so we have one plot like this. So one plot would be about 50 meters, which is around the size of one of your plots, long, but only around 20 meters wide. And that makes it easy to kind of measure with kind of 2 sub-teams up and down that plot. And in different sections of the plot, you can see the different colors of blue and black and light blue and white. We're measuring trees only over a certain diameter, a certain circumference, because we just want to take subsamples, because otherwise it will take too long to measure every single tree. And then what we do is we put that, this is one plot, and we put it in with a group of plots. So on the left side here, you can see there's 8 of them. And each one of these, if we go north, and each one would go east, that whole distance, north to south, is about the size of about the length of one football field. And we do it again east, also around approximately the length of one football field. So these plots are really long. They can take 2 or 3 days to do all of these plots in that kind of forest. Then we have to make sure that, and then there's different ways to do them, right? If depending on the different forest type, you might want to have a lot of space, so you might want to have larger plots with larger gaps, or smaller plots with smaller gaps. It really depends on the forest type. There's no one way. And then you want to make sure that your plots all are within one type of forest, so that the forest doesn't change in the middle of the plot. But unfortunately, it's not this easy when we're looking at satellite imagery. I wish it were, but when we're looking at satellites, it looks more like this, right? Where we see a bunch of forest cover, and we kind of know what it is, but sometimes we don't. There's shade from the hills that makes normal forest look more dense, but we do the best we can, and we estimate based on our knowledge what types of forests we think they are, and then we go out and we survey them. So here you can see there are 3 plots on the left that are nearby to a village called Ban Ponsak here in Laos. And here's some more plots, one in the southwest, one in the northeast, in Ban Nakrian. And so just to give you an idea of kind of how we detail where those plots go on the ground. Once we do that, we can figure out the best way and the most efficient way to get through the forest and to the plot. Sometimes it can take a whole day just to walk to the very first plot, and then we have to sleep there and for about 3 days until we finish the whole transect and then come back. Okay, thanks.
Thanks.
Okay, Gabe, we're getting towards the end of our time here. I want to see if any of our other students have some questions particularly to ask you. Anyone have something that's standing out that they don't understand about our process or don't understand about his process? Okay, we have one more group of students that's just going to ask you for a little bit more advice.
Okay.
Okay, what advice can you give us when we go back out to collect more data?
What advice can I give you?
Yeah.
I would say think about how you might be able to mark those trees in a more permanent way, so that maybe other classes after yours can go back and measure those same trees and know which tree they're measuring. They can see how much it grew from when you measured it to when they measured it, and therefore how much carbon is now on the tree, how much carbon went into that tree. That might be one thing to think about. I would say be careful as much as you can with the chronometer. Make sure to keep it nice and level. You might be able to tie a string on the bottom with a little weight. That'll keep it up and down. That'll keep it nice and parallel. It's called a plumb line. If you want to try that, you can give that a go. It's pretty easy to do. And I just say, be careful with your measurements. Otherwise, I think your design looks really good.
Okay, thank you.
All right, Gabe, thank you so much for your time. Really helped us with some information and some feedback here. And I hope that we can be getting you some data soon, and you can give us some feedback on how we analyze it.
I look forward to it. Thanks a lot, guys.
All right.
I really enjoyed talking to you.
All right, thank you so much. See ya.